All right, let's take a look at number 6. Specifically, what type of problem would this be? It says, what is the measure and reference of the reference angle in degrees for an angle that measures 1230 degrees? What type of problem would this be? Students got this right 60% of the time. What type of problem would this be? I hear triangle. I actually, though it says reference angle, which comes from a triangle, I don't put this as a triangle because triangles, when you use log sines, log cosines, like you actually physically see a triangle. So I wouldn't actually include that in here. It's the analytical trig. Okay, so I said this on number 2. There's a lot of extra on number 2, but on this one I'm going to do it. When you do come to the analytical trig, this is the one part of the test. This and conic section has a few things to have memorized. That if you memorize just a few things, you'll be set up in a great location for analytical trig problems. That just means when you look at the problem, you have no picture, there's nothing like that. You either get some trig function, a degree, something like that. Here's what is really helpful for you to remember. That when you draw this, that this horizontal line is called a x. This line is called a y. If you can remember those two things, if you can remember that sine is y over h, sine is y, cos is x, tangent is, and one more thing, the Pythagorean theorem. X squared plus y squared equals h squared. And then finally, the angles. This is in degrees, so if you can remember, this is 0, this is 180, this is 360. If you can remember those things that I have written up right there, you can solve your analytical trig problems. Okay, so it falls under knowing this information. So it says find a reference angle in degrees for an angle that measures negative 1230. Well, could we put negative 1230 on that? What's the problem, Guadalupe? What's the problem with negative 1230? Okay, it is in degrees, which is actually okay. What's our problem? Frankly, the things you need to remember, I need to also put, it could be in radians if you want to. So I'll put that on there. But what's the problem with negative 1230? Technically, it's actually too small because it's negative. So how do I fix that? Add 360. Go to your calculator and let's add 360. Calculator. So take your negative 1230 and add 360. What do we get? Now, is that a good angle? What's the problem with negative 870? Too small. That's called a coterminal angle, by the way. Whenever you add or subtract a full circle, it's called coterminal. Here's another coterminal, negative 510. Is that good? What's the problem? Still too small. So I add another 360. Press enter. Is that good? Jesus, what do you think? Negative 150. Is that good? Well, it's not perfect. Why is it not perfect? Still negative. How do I make it bigger? Add another 360. Let's find another coterminal. Coterminal. Co means together. Terminal means ending. Something that ends together with it is 210. Is 210 fine? All right. I'm going to put on my graph a little sketch of where 210 degrees would be. So I know I'm using a vector here, but just bear with me. 210 is past 180. It's over here. So what reference angle means, and this is why Lewis, if you heard him say, triangle, is 210 degrees is right there. If you were to graph that, I know I used a vector, that's 210 degrees. What a reference angle is the angle that connects to the nearest x-axis. If you were to connect this to the nearest x-axis, you're asking yourself, how many, in this case, degrees, does it take to get from 210 to the closest x-axis, which needs to be 180. How many degrees apart is 210 and 180? 30. That is your answer. Now, are there calculator cheats? Yes. a reference angle. It doesn't matter which trig function you pick, but no matter what you pick, you'd always get the same decimals. You might not get the same positive and negative answer, but you'll get the same decimals. For example, if I did sine of negative 1230 degrees, and you press enter, and then I did sine of 30 degrees, you'll notice you'll get the same decimals. It won't necessarily be the same positive and negative. You see how these are different? But no matter which trig function you get, they should always give you the same decimal. I'll show you tangent because tangent will be both the same. They'll both be positive. If you're wondering, how do I know tangent will be positive on both? That's because this has a negative x and a negative y, and tangent has this y over x. The negatives cancel, so I get a positive. And then I do it again of 30 degrees, and I'm going to get a positive as well, because 30 degrees is honestly first quadrant value. Everything's positive there. You see how no matter which trig function I pick, they got the same decimal? A reference angle will always give you the same decimal. So tangent gave it the same as tangent, sine gave the same as sine. Same decimal between whichever trig function you pick. The only thing that might be different on a reference angle is it could be positive and negative, and that's okay. Reference angle, that part doesn't matter. So that's the way in the calculator of doing reference angle as well. Questions on number 6? Before I move on, what is sine? Cos is, tangent is, and the Pythagorean theorem? X squared plus y squared equals h squared. You can n solve those. As long as you know that part, you can n solve the rest for any problem.